All right, new section. New section. We have section 1-4. Okay. Thank you. All right, it's called solving radical equations. Okay, what do we know about? We know solving equations, right? We solve for x, basically. Okay, not all the time, but yeah, I think all of these that we're doing today, yep, we're solving for x. And we've done that. We've done that all year, haven't we? Solve for x. Okay, what about this word radical? Back in the 80s, that was like a phrase that you would use, like if something was crazy and wild and something like that, we say, oh, radical, right? I didn't say it too much. I probably wasn't cool enough back then to say it, but all the cool kids said it. But anyway, they say radical. But that's not what we're talking about. What are we talking about? And we've been talking about it recently. What is a radical? It's like a square root, right? Okay, it's that thing right there. It could be a square root. It could be what other kind of root? Cubed root, fourth root, fifth root, and so on, okay? So what does a square root do? Before we actually do the example, what does the square root do? Like if I had the square root of 9, what number times itself, right? 3. Okay, it's 3. But what number times itself? So what two numbers that are exactly the same multiply to be 9? Okay, 3. And we also learned what else, though? -3, okay? But we'll just put 3 right there. And we've talked about this before. What if you had the cube root of something? I'll tell you what, let's do a different number. Let's do 8. What if we have the cube root of a number? What is that? Is that just two numbers that multiply, two of the same numbers that multiply to be 8? 3 of the same numbers, okay? Not just 3 any numbers, 3 of the same exact number, okay? So what times what? Let's say it this way, not what times what. What times itself again is equal to 8. It's 2. You with me? Okay. So these things, this little check mark looking thingy, okay, this is called a radical. We've discussed that before. That's nothing new. So let's jump right into it now. Example 1. By the way, what if, let's do a little bit of teaching before we jump into it. What if I said this? What if I said the square root of x equals 5? Okay. How would I get x by itself? Square root? Square it, because I do the opposite. What's the opposite? What's the opposite of square root? It's a square. So I square this side so they cancel out. Okay, then I square this side. Agreed? What if I had this? What if I had the cube root of x? Then what would I do? Say it, Nana. I cube both sides. That's right. Okay, right here I would square both sides. What would I do with a cube root? I would cube both sides. Agreed? All right. And then the cubed and the cube root cancel out. That's x. And then I do that, whatever that is, and that's 8. Okay? Now, that should help you a little bit with this example. And then -2. This -2 is not inside the square root, of course. How did I think you were going to ask a real question? I don't know. So what if I did that? The cube root of 2x minus 4, and then I got this -2. Kind of got it floating over here a little bit too far, but there we go. Everybody see that? See, the -2 is not under the cube root. It's sitting there by itself, equals 0. So let's think about what we're going to do here. What do you think the first thing that we're going to do? Because we want to solve for x, right? All these say solve. What are you going to get rid of? You sure? What if I had this? What if I had like 3x minus 2 equals 7? What would I get rid of first? I'd add the 2, wouldn't I? Okay. I'm not adding like terms. I just add the 2 to the other side. Exactly right. Okay? So look, always get rid of what's being added or subtracted first. Everybody hear me? Always get rid of what's being added or subtracted first. Then you can get rid of the stuff that's being multiplied, divided, square rooted, squared, all that kind of stuff. Okay? But if there's something that's just being subtracted or added to this, get rid of that first. You don't get rid of the 3 first. Agreed? All right, so you come over here. What's the first thing we're going to get rid of here? This. The 4 is underneath a cube root. So you get rid of that 2 first. Okay, let's get rid of the 2 first. How do we get rid of that 2? You add a 2 to both sides. Add it to the 4. Look, the 4 is under a cube root. This is not just sitting there by itself. I cannot add the -4 and the -2 together. Okay? It's like this. I can't take the 3 and subtract 2 from it, can I? Because that 3 is doing something else. It's multiplying by the x before you're subtracting it from the 2, or subtracting the 2 from it. All right? So you cannot take the -4 minus 2, because the -4, all this stuff, it's kind of locked in, right? It's locked in under the cube root. So I can't get rid of that stuff unless I get rid of what? The cube root. I got to get rid of the cube root first before I can mess with this stuff in here. Everybody understand that? Yeah. Okay. So let's add a 2 to both sides. All right, let's see what we get. I've got a cube root of what? 2x minus 4. So I didn't do anything to that, right? All I did was get rid of this -2. And that's equal to 2. You with me? Yes. All right, pretty simple step. That's baby stuff. That's pre-algebra stuff. Okay, now is when we're starting to get into a little bit more intricate stuff. We said this up there, right there. How do we get rid of a cube root? You don't cube root the other side. It's not a cube root. You cube it. It's different. It's completely different. Okay, it's the complete opposite of cube rooting something. Okay, cubing something is the complete opposite of taking the cube root of it. All right, so we can't just say cube root and say, whatever, you know what I mean. You can't say that. All right, you have to cube both sides. Why do we cube both sides? Because it cancels out the cube root. A cube and a cube root cancel each other out. A square and a square root cancel each other out. Okay? What if we could go further? A 4th root and something to the 4th power cancels each other out. You with me? Yeah. Okay. I'm going slow. I'm explaining every little thing that I'm doing here. Do you agree? Okay. So, how do we get rid of the cube root? Cube this side and cube that side. Cube both sides, not just one side. Now, why did we cube this side right here? So that what happened? The cube root cancels out. That's right. So this cube cancels out with this cube root. So what am I left with then over here on the left? Just the 2x minus 4. Now let's do this. We can do this math in our head. What's 2 cubed? It's 8. Okay? Now you got to be really careful. I'll say this. When you take any side to a certain power, sometimes weird things happen within the problem. Everybody listening? We're going to do this in a second. But when you cube both sides, or you square both sides, or you take both sides to the 4th power, or whatever power, okay? Sometimes weird things happen to your problem. So what you're going to have to do is you're going to have to check to see if your value for x actually works. Sometimes it's fine, right? It works perfectly. Sometimes it doesn't. So we're going to have to check to see if it does. Why? Because weird things happen. That's the only way, that's the best way I know to explain it. Weird things happen when you cube both sides or you square both sides. Okay? So let's do this. Let's finish this up. We should be able to do this pretty easy. This is pre-algebra stuff right here. What's that? 12. X is what? I'll show every step, so I'm not leaving anything out. So x is 6. So it'd be nice if we just circled it and we said that's our answer, we move on. But sometimes, not all the time, sometimes weird things happen when you square both sides or you cube both sides or whatever. Okay? So what do we have to do to this? I cube both sides, so that is an indication to me that I'm going to have to plug it back in and see if it actually works. So let's plug it back in and see if it works. Where do we plug it back in? To the original problem. Okay? We plug it back into the original problem before we cubed it. We could have actually plugged it into here, but we don't want to plug it into this. We want to plug it into this one before you actually cubed it. But let's put it into the original one. So let's do it. Let's check. So I'm going to write check. All right? And so what do we have? We got a cube root. We got a 2 times x. What did we get x to be? 6. And then minus 4. Remember, this minus 2 is outside that cube root. Remember, this is a cube root. Okay? You with me? All I did was plug in what I got for x in for x. And let's just see if this actually works. Now, that should equal what? 0. I'm going to put a little question mark there, okay? I'm not sure right now, but I want to see if it equals 0. If it equals 0, we're good to go. All right? If it doesn't mean necessarily that we made a mistake. It means sometimes there's not an answer for this. Now, there is for this one. There is for this one. But every once in a while, there's a situation where there is no answer for x. There is no x that works for that particular equation, okay? All right. So let's do this. What do we got in here? 2 times 6 is 12 minus 4 is 8. All right. I don't want to do too much in our head. You can do that much, though, can't you? All right. So it's the cube root of 8 and then minus 2. So what is the cube root of 8? We've said that already. It's 2 minus 2. Does that equal 0? Yes, it does. It checks. So now I can come over here and do what with x equals 6? Now I can circle it, okay? And we're good to go. So that was pretty basic, wasn't it? Really, was that very difficult? No. Pretty simple. What do you think? I just gave you a big old long talk before I started recording. What did I say? I said it will get harder. So let's do this one. This one looks easier, but it's a little tougher. A little bit, not much. But every single step that we're going to do in this problem, we've done before. Okay? I've taught you how to do this before. We just haven't put it all together. That's all. All right? Trying to get x by itself. Well, this is a little different because I got an x on the left-hand side and I have an x on the right-hand side. So that makes it a little bit different. Okay? This is just a square root. It's not a cube root. It's just a square root. So what do you think is the first thing that I want to do? Yeah, I would square it. I want to get rid of that square root first, okay? There's nothing being added or subtracted to it, so I don't have to, remember that minus 2 on that other problem? I don't have to get rid of anything right there. If I had a minus 2 outside that square root, I would have to get rid of that first. But I don't have anything else. The only thing on the left-hand side is that square root. So I get rid of it. I square it. Now, here's where you got to be careful. Everybody watching? I got to square the whole entire right side. So I put it in parentheses, and I put a squared right there. That's super important. It looks like it's not that big of a deal, but putting those parentheses is crazy important, okay, because we're squaring the whole entire right side, okay? What happens when I square that square root? Cancel out. What am I left with on the left? X minus 1. What about this? It is a FOIL, but let's write it, because remember, we've done this. We did this very recently, didn't we? I think we did this on the quiz. When you have something squared like that, yeah, it's that one with that square root of 3 over 2 or whatever. Yeah. So what do you do when you square something? You multiply it by what? Oh, I say this 100 times. You multiply it by itself. When you square something, you multiply it by itself. Oh, you make me so sad. I say it so many times. I thought for sure you guys would get it. Okay. Everybody with me on that? Everybody's good, right? From there to there? Yeah. All right, let's keep going. I'm not going to get rid of that 1 just yet. What do you think I'm going to do? I'm going to FOIL this. Okay, so let's FOIL that. So first outside, inside, last. Now, I'm going to go a little quick on this because we've done this 100 times. Well, maybe not 100, but probably close. Okay, so we multiply these together, x times x, which is x squared. The outside is negative 7x. The inside is negative 7x. And the outside, or the last, is positive, what? How about 49? 7 times 7. That's all right. Let's simplify this. You could have probably done this in your head. You probably could have gone from here to this next step right here in your head. A lot of you could. If you can't, write down the steps, for goodness sakes. There's no shame in writing down more steps than you need, all right? As long as they're the right steps, I should say. All right, here we go. X squared, what's this? Negative 7 minus 7. It's negative 14x. And then you just drop this plus 49 down. All right? We're getting there. We're getting there. What do you think? Why don't we get rid of this minus 1 right now? Okay, so we get this x by itself. Is that all right? So let's do it. So let's add a 1 here. Where am I going to add the 1 to? The 49, right. All right, so let's bring this down, x. In fact, we could also, let's do this in the same step. This kind of looks like a quadratic, doesn't it? But what do we always want our quadratics to equal? We always want to set it equal to 0, okay? So let's do this. Here's our quadratic right here, agreed? So let's take the 1, move it over here, and then let's take the x and move it over here as well, right? Why would I do that? Because I want this to be what? 0. I want it to be equal to 0. Because we know we could either factor, we could complete the square, or we could use the quadratic formula, right, to solve for that quadratic equation, as long as it's equal to 0. Let's see what we get now. I've got x squared. What's negative 14x minus x? Negative 15x. And then 49 plus 1 is 50. Okay? Right, it equals 0. Now, we're used to having that 0 on the right-hand side, aren't we? So let's just do it, just to make us feel a little bit better. So now this is a quadratic, isn't it? All right? It's not as hard as it seems. This is an easy one. Now, if you didn't realize it, you could, if you wanted to. I'm not going to on this problem, but if you wanted to, you could put this into the quadratic formula. And you're going to get the right answer every single time, as long as you do the problem right. Okay? But this is kind of an easy one. This will factor. Then they won't always factor. Sometimes you're going to have to put it into the quadratic formula. But this one does factor. Do you see what we're going to use? 5 and 7? Oh, 10. Yes, 5 and 10 would work. Okay, because watch. Because 5 times 10 is 50. And then 5 plus 10 is 15. But this is a negative 15, isn't it? So what do you think this is going to be? Well, you know this is going to be x and x, right? It's going to be a negative and a negative. And so what do you get? 10 and 5. All right? So that wasn't hard if you realize that it factors. If you didn't and you don't like factoring, by all means, go ahead and use the quadratic formula. Okay? We've done that recently. It's fresh in your mind. If you want to use it, you can. I'm not going to because it factors so nice and easy. So what happens when these two things are multiplied together and your answer is 0? You set them both, what? Equal to 0. Have we done anything new at all today? We haven't done anything new. Everything that we've done so far, we have done before. Okay? So what is x? X is 10 and x is 5. But don't circle them. But I always told you to circle your answers. Why aren't we circling? Got to check. Well, if you don't, there might be an answer in here. Maybe one, maybe both don't work. All right? Well, there's not 3. So it's not all 3. So what was the original? I'm going to write the original problem down. All right. So let's see if I stick my values in for x, let's see if they both work. Or let's see if only one works, or maybe none of them work. Or maybe both of them work. Did I say both already? Okay. So let's try it. Let's put in a 10 and see if 10 works. All right? So what do we get? We can do this in our head. What's 10 minus 1? 9 equals, what's 10 minus 7? Does the square root of 9 equal 3? Yes, that works. So I can do what? I can circle x equals 10. Now, does that mean because that one works, the other one automatically works? It doesn't. Now, it could. It could work, okay? But it may not work. What's the only way to figure out? Let's check it. All right, so again, let's use this original equation, and let's put in a 5. So let's do a little bit in our head. 5 minus 1 is 4, so it's the square root of 4. Let's put a 5 right here. What's 5 equal to? 5 is equal to...
We did it wrong.
No, I'm just... All right. For you two, I'm going to go ask the master mathematician. So here we go. I was thinking, because the square root of 4, we have said before, the square root of 4 is plus or minus 2, correct? All right, so we could use both. But we use the plus or minus if we're solving an equation. If you're plugging it back in to see if it works, we always use the positive version of it, okay? So I didn't know a good way to explain that. He explained it well. So I'm not going to use plus or minus 2, plus or minus 2. What am I going to use? Just 2, all right? Now, what did we say this was? If I put 5 in for this, 5 minus 7 was what? Negative 2. So does, put a question mark right here, does 2 equal negative 2? No, it doesn't. Okay, so can I circle x equals 5? No, I can't. So my only answer is x equals 10. So here's the deal. Listen to me. Write it down if you need to. If you have a test or a quiz, all right, and you have this problem, and you write both of these answers, if you do this, all right, and circle them both, guess what happens? It's wrong. Put an X, okay? That's what we're studying, okay? That's what we're studying. I have to put it on the quiz. See if you know what you're doing. So do not circle x equals 5. If you circle them both, it's going to be wrong. You can only circle x equals 10. Everybody got that? Write it down, because I don't want you whining and crying. Mr. Hamrick, I did it right. I got both those answers. But the thing is, x equals 5 doesn't work, all right? X equals 5 does not satisfy the equation, all right? That's what mathematicians say, all right? Doesn't satisfy. It doesn't make the equation work. Only 10 does. You with me? All right. So it's very, very important that you check. It's super important. Somebody asked a question before we did this. Do we have to check?
I asked that.
So do you?
Yes, we do.
I would say yes, because, right, you could do this whole thing. You could always guess to see which one works and not check it. It's fine with me, I guess, but you're going to get it wrong, all right, if you circle the wrong thing. Okay, enough of that. Now, for what everybody came here for. I don't know if we're going to be able to finish this today, but we'll get started at least. So here it is. If you're like at the end of your paper or in the middle of your paper, I would flip it over and start at the very top. Okay? There it is. That's my problem right there. That's one question.
Just for this little thing?
Come on, be tough. Be tough. Be mentally tough. Again, we talked about that yesterday. Sometimes it's way harder being mentally tough than it is physically tough. All right? So let's be mentally tough, and we'll get through this. Okay, I am recording it. You are writing it down. So I'm just going to go step by step, and I'll just show you what we're going to do. First thing we're going to do is I got 2 square roots on the left-hand side. I don't like that, okay, because it's going to be too hard to get rid of the square roots. I can't just square this and square this. I would have to square the whole thing, and then I would have to do FOIL method with these 2 things, and that would be super ugly. Now, would it work? Yeah, it would work, but man, it would be a mess. All right, so first thing I'm going to do is get rid of one of these square roots. Which one would be the best square root to put on the other side? The minus one, right? Because if I can add it and put it over here, and then it's plus. Would you agree? So let's do this. 2x plus 3, let's extend that a little bit, equals, let's see, where I put the 2 on the end. Okay, I took that 2 and I just slid it over, and then I put this right here. Plus 2. Okay, so all I did on that first step was add this square root of x plus 2 to the other side. Took that 2, slid it over to the right, and then I stuck the square root of x plus 2 right in there. Okay? Now, we are going to have to do a FOIL, but it's not going to be as bad as foiling this. It would be super ugly to FOIL that thing right there. Would you agree? All right. Now, it's already going to be a little bit ugly, but not near as bad as it would have been if we FOILed the first one. So what we're going to do is try to get rid of the square root. How do we get rid of the square root? We square it. No, we don't square root it. We square it. Okay, so we square both sides. So I square this side and I square this side. Make sure that you put that in parentheses. We talked about that on the first example. Make sure you put that whole thing in parentheses and squared it, because what we're going to do is we're going to split it up, right, into two parentheses, and we're going to FOIL that. So what happens here, the square gets rid of the square root, so I'm just left with 2x plus 3 equals, and now, what do we do when we square something? We multiply it by itself. So there's one, and here's another. This is probably the worst part of this problem, is this right here. Okay? But you're going to find out it's not really that bad. It looks bad, but it's not so bad if you understand FOILing and you understand how to multiply square roots together. So let's see what we get. We get 2x plus 3 equals. Now let's do the FOIL. First, outside, inside last. So first, it's the square root of x plus 2 times the square root of x plus 2. Is it 2? For instance, watch. What if I just had the square root of x times the square root of x? What's that? It's x. What's the square root of 5 times the square root of 5? It's just 5. What's the square root of x plus 2 times the square root of x plus 2? Just x plus 2. So that wasn't so hard, right? Do you agree? Yeah. Just got rid of the square root. Easy, right? If you watched, it's easy. You can't say that's hard. You can't. It's super easy. So now, let's do the outside and the inside. So the outside is this thing right here times what? Times 2. Those are your outside terms. So how do I multiply that together? Put a plus because everything's plus. It's just 2 square root of x plus 2. Right? So this times 2. It's just 2. What about the inside? Same exact thing. So it's another 2 square root of x plus 2. Plus the last terms, 2 times 2, that's super easy. That's 4. All right, let's see what we can do. It's a lot of steps, but none of the steps have really been that difficult so far. That was probably the hardest step, I think. Yep, that's probably the hardest step out of the whole entire problem, what we just did right there. And that wasn't even that bad. Let's do this. Let's add some like terms together. Well, I got an x. I got a 2 and a 4, don't I? So let's add those together. I get a 6. Now, how do I add these two together? Well, let's go back in time again. What's 2a plus 2a? 2 apples plus 2 apples. What's that? 4 apples. Very good. What's 2x plus 2x? 4x. What's 2 square root of x plus 2 plus 2 square root of x plus 2? 4 square root of x plus 2. Okay? You see that? 2 apples plus 2 apples. Our apple happens to be a square root of x plus 2. All right? We good? All right. So now what we're going to do, let me see what we're going to do here. Yeah, let's do this. Let's try to get that square root sitting there by itself without all that stuff being added to it. Okay? So this part right here, you might have to think a little bit, but maybe put a little note in here, put get square root by itself or something like that. Okay? So that you know why we're doing what we're doing. So if I want to get that square root by itself, what do I have to get rid of on that right side then? I got to get rid of the x, and I have to get rid of the 6. Okay? Once I do that, then I can worry about getting rid of the 4. But the 4 is being multiplied, so I get rid of what's being added first. Okay? So I subtract an x from both sides, and I subtract a 6 from both sides. Subtract an x, subtract a 6. Why did I do that? Because I want to get that square root sitting there by itself. What do we get? 2x minus x? That's x. This is minus 3. 3 minus 6 is negative 3. So far, so good. Those cancel out. I'm left with 4 square root of x plus 2. Okay? Now, it would seem like, and I kind of said it earlier, and I probably shouldn't have, it seems like we would want to get rid of that 4, doesn't it? But the problem is, we could, it'll work, but the problem is going to be kind of ugly, because I'm going to have x over 4 minus 3 over 4, and that's going to be really ugly. Would you agree? So I'm going to do something else. Make it a little bit easier. I want to get rid of that square root, don't I? So how do I get rid of it? Got to square it. But you got to be careful. Listen, you got to be careful because that square root is not just sitting there by itself. I got this 4 out in front of it, don't I? So I'm going to have to square that whole entire side. This is where it gets a little bit tricky. So write it down. Now I got to square the whole entire left side. But what do I need to do with that? Put it in parentheses and square it. And I will FOIL it. You're right. Okay? So let's do that. Let's FOIL this left side. So I'm going to go x minus 3 times x minus 3. Let's just do that first, then I'll come back to this. Is that all right? Can we do this in our head? We should be able to. It's x squared minus 3x minus 3x, which is minus 6x, and then plus 9. Agreed? All right. You can show the step if you want. Now right here, we got to square everything in here. You don't have to FOIL it because that 4 is not being added to this, okay? It's being multiplied. So all I'm doing is taking 4 and squaring it, which gives me what? 16. Now what happens when I square this square root? It cancels the square root out, so what am I left with? An x plus 2. And what is that x plus 2 doing to that 16? It's being multiplied. That's right, it's being multiplied, so I put it in parentheses. That might be one of the trickier steps right there. Okay? I warned you it was long, but it's really nothing on here is anything we haven't done before. Okay? What do you think you would do now? Well, I would probably distribute that 16, wouldn't you? So let's do it. It kind of like every step just kind of opens up before us when we look at it. Maybe not every step. A couple we had to really think about. That one you didn't have to think about. You saw it and you're like, oh yeah, distribute. So what's that? 16x plus what? 32. Now, we're close to having a quadratic, aren't we? Everybody see that? So let's get everything on the left-hand side set it equal to 0. Let's do this one step, then I'll let you go. Watch. Negative 16x and then minus 32. Negative 16x minus 32. So let's see what we get. X squared. What's that? 22 minus 22x. And what's that? Minus 23 equals what? 0. Now, here's what you're going to do. You are going to do the rest of this at home. You're going to get x, and then once you get x, you're going to plug it back into the original problem and see which ones work. I'll tell you right now, only one of them works, okay? This actually factors kind of nice and easy too, okay? It factors, okay? So do the rest. So here's your homework. It's pages 122, 123, and you're doing... Now look, you're not going to... Let's see, what did I... Hold on. Right, but listen, it's a lot. It's just the odds, okay? But listen, I'm giving you 2 days to do it, okay? I'm giving you today and tomorrow to do this. So you don't have to do all of that tonight. Do some of it, though, okay? That's it.